Okay, so in this lesson, or in this video, I'm sorry, I'm actually going to do lessons 16, 17, and 18. I think this is the way I could figure out to make it most fair for the students that are off on Memorial Day on Monday. So rather than having you kind of work through all of them, I'm actually going to do all the puzzles so you're able to follow along. This is really the only way I could think of that would allow us to finish what I had planned. I completely forgot that we had Memorial Day off. You know, the schedules have just been weird, so I'm gonna do this to hopefully fit it in kind of a shorter amount of time for you this week. This is optional if you're able to, especially those of you guys who I still see on Tuesday, Thursdays, meaning periods 2, 4, and 6. I would love you guys to do it with this week's work without the this video, but to make things fair, I'm just gonna share this with everyone. Okay, so this video is going to be lessons 16, 17, and 18. You're going to notice that when I go to the new code, it's going to give the answers. I'm going to reset it, and that's just because that's how the thing saves. Okay, so lesson 16 puzzle, this is just the lesson overview. It's going through some of the vocabulary and the code you're going to be learning. On OneNote, I kind of explain what the goals and objectives are to make it faster. I'm not going to go through all that in this lesson, but I'm going to read the directions and kind of go over it, and you'll probably see it from my perspective. So puzzle 2, lesson 16, you're going to look at the frog jump, and then what you want to consider is what code do you think would help the computer to know whether the sprites are touching. Okay, well, that's going to be something we sort of look at number 3. And this is actually the written out code, but we're not going to be doing this. Okay, so I wanted to go through that first because I know a lot of you guys are going to start looking at the directions, and then you're going to kind of notice the huge blocks of orange down here. This is the entire code written out in its entirety. We're going to simplify things in this lesson by using what we call abstractions. So we're going to simplify representations of something more complex. So rather than focusing on this or this in the orange, we're going to simplify the code for you. Okay, so I just wanted, or the point of number 3 is just to point that out. Okay, moving on to 4, let's go ahead and start over, reset it. Let's take a look at what we need to do. So we're going to learn this new code is touching. So instead of writing out the math each time you want to check whether 2 sprites are touching, that could take a while. So programmers created the is touching block, which can check whether one sprite is touching another sprite, the target. The computer is still doing the same math as the previous program, but you don't have to worry about it because another programmer, they already coded, this whole mess, and they turned it into one single block. In this case, the is touching block. So inside the draw loop, we're going to drag the is touching block into the if block, and we can click show me where, and it's right here. So what we're going to do is if sprite is touching, and we're going to do it if the balloon is touching the tack. What happens? Well, let's run it, and we're going to be able to move it, and it pops. Okay, I should have gone over the code with you guys, but the rest of the code is just us moving the tack. Okay, on to number 5. Let's go ahead and reset it. Okay, so applause. When the apple hits the blender should turn on. This code is really loud, so just a heads up. But we're going to use this touching block to make the blender shake back and forth when the apple sprite touches the blender sprite. The shaking motion is already coded using the random block, so you just have to check when the 2 sprites are touching. So we can't run it because there's this blank code here. So what we're going to have to do is do what it told us to do. Use this touching block to make it shake back and forth. So we're going to practice using this. So if the blender is touching the apple, and again, they recoded the X value is going to change and move back and forth. That's what this is. It's at 200. It's going to sometimes go left 5 pixels, sometimes go right 5 pixels, sometimes -3, sometimes +3. So let's go and run it. And Oh, sorry, it's not loud because we don't do the sound this one. But it is going to touch and it shakes. The next thing is, can we make the apple disappear? We can by just using the visible sprite. I guess I'll just do it since it only takes a second. And we'll change the apple visibility to false. Okay, so now when it touches it, the apple disappears. So that was number 5. Let's look at number 6. Let's reset it. And so this is the one that's really loud. We're going to now play the sound. So if they're touching, and it should have been saved from before, so let me quickly do that. If the apple is touching the blender, it shakes, and we also want to play the sound. And to do that, we're going to use the play sound block from the world drawer. And we're just going to copy this URL onto here. Okay, so lower your volume because it's going to be pretty loud. Oops, what's wrong? So it took me a second, but I actually don't know what they did wrong. I just reset it and pasted the link again. I think I accidentally deleted one of the quotation marks now that I think about it. But it should be working, and if we run it, again, it's really loud, so I'm just going to move on to the next one. But that was number 6. So for 7, I'm going to hit start over. When the rainbow touches the horse, we want to turn to a unicorn. So we're going to use the if is touching and set animation blocks to change the horse's sprite when the rainbow touches it. The unicorn image is already loaded into the animations tab for us. So we have the horse, we have the rainbow. Let's go ahead and run the code to see what happens. The rainbow's moving diagonally up, horse is staying the same. So we want to now use the if block, and we're going to say if the 2 are touching, horse touches the rainbow, we want to change or set the animation, horse animation, we want to change that to the unicorn. And we're reset, and there we go. Okay, number 8, and I don't remember the puzzle step by step, I'm just quickly resetting it. The balloon is popping before the tack touches it. When sprites aren't doing what you expect, what can you use to debug the block to get more information about why the sprites are behaving that way? Okay, so in this one we're just practicing the debugging. So let's run the code, and we're going to notice that it pops early, right? Did you see that? Let's look at it again. The tack should pop when it touches the balloon, but it pops like right here, okay, around here. So what's wrong? We're going to use the debugging, and to do that we're going to change the debug from false to true from there, and we're going to set another one for the tack. Where is it? Oops, not console log. There it is. Don't remember where all these blocks are. So the tack is true, and once we run it, now we notice that there's this big rectangle around it. So we're going to notice that the balloon's I guess detector is all the way out here. So as soon as I pass that line, it pops. So that's what's wrong with it. So the challenge was to use the animations tab to resize it, and to do that, what we want to do is for the balloon, we simply just crop the sprite. Okay, and if I go back, and that's a challenge, that's why I'm doing it quickly, you don't have to do that. You're going to notice now that the balloon is all the way down here. It's not perfect still, but it's a lot better. So that was number 8. Let's look at number 9. Let's reset it. which one is this? So we're going to set a scoreboard. It looks like you can use the is touching to decide whether it should increase the score. In this game, the score is stored inside the score variable. It's displayed on the screen using the text block. Okay, so I'm going to run it, and basically we just want to make give us points whenever we touch the carrots. Notice how it just goes through and nothing happens. So let's make sure we do the 3 things it asks for. Use the counter pattern on the score variable to increase the score. So let's take a look at our code. We have the bunny, set to a bunny, it's right here, carrot, and we're making the carrot move to the left right here. We have the score set to 0. We're drawing a light blue background. For the green grass, we have a black top, green grass, and that's the grass, the rectangle. The score is written up here. We have the score. That's where the score is. That's the size of the text. And notice how this is in quotations. Hopefully you know this by now, but the quotations means it's the text. And here, since we don't have the quotation marks, that's the variable score. And it's written right there. So what we want to do, let's actually look at the rest of the code. So if the carrot if the x value of the carrot, meaning if it goes past here, it's going to, we're gonna move it back to the right side of 450, which is past the 400, so it's around here. And it's going to be, the y value is anywhere between 10 and 390, so it's going to be in this field. Whenever we press this to make the bunny jump, if the bunny is over 344 is the grass essentially. If it's at 340 or more than 344 and we press up, it's going to jump. And that's how fast it jumps. Okay. If we don't press up, it stays at 0, meaning we don't change it. Or else, I'm sorry, not or else. If the y value is less than 80, meaning when it gets to the top, we actually change the y velocity to 8 to make it go back down. So now this is what we have to do. Let's use the counter pattern on the score variable to increase the score. So what we're going to do is we're going to set the variable. Let's do it right here. Oops, we want to use, do we have the touching yet? We might have to add the touching. I guess we have to do the if. It doesn't tell us. Oh, it does say if right there. So we're going to use the if and is touching block. So if the bunny touches, if the bunny is touching the carrot, okay, that's the first thing. These are the 3 things we want to do. Use the counter pattern on the score variable to increase the score. So that's where we're at before. So score is going to be score plus 1. Why is this? Oh, I think this should be okay, right? Why is it? Okay, let's run that. I think that should work. Okay. Oh, I see. So there it goes, and we notice that the score is going up. We're not done yet. We still have 2 more things to do. We're going to reset the X position off the right hand side of the screen. So what we're going to do is when they're touching, we're also going to move the sprite, the X position of the carrot, right, to the right hand side of the screen. So we'll use the same values they do, which is, what is it, 450 right there. So we're going to set the X value to 450. Reset, and once the carrot touches, the carrot resets, and you notice that the score only goes up by 1 each time, and that's because it's not touching, for all those frames. Okay, as soon as it touches, the carrot moves, so they're no longer touching. Then we're gonna also reset the Y position. See, notice how it doesn't do that right now because once I touch it, we just said to set the X, not the Y. So we're going to do the same thing, and we can just copy and paste. I'm just going to do that here, copy, and we're going to paste it right. Oops. I actually don't even know how to copy and paste the blocks too well. There it goes. Copy and paste right there. No, reset and run it. Now the Y value is also a random number. So that's number 9. Let's look at 10. Okay, for number 10, where, oops, I need to reset it. If we're gonna use as touching. Oh, okay, and we're gonna use the play sound to make things happen when our sprites run into each other. There's also the option of looping, and we'll talk about that when I set it up. So let's take a look at the code so far. We have the frog and the mushroom. I think because it reset everything, some of them are linked up. So I'm actually going to go back to a version I already have, maybe from 5 days ago perhaps. So this has the code done already, but it lets me kind of explain what we did. Is it done? Let's double check. Okay, so it is. So let's actually see what I did so far. I added the 2 effects. I don't remember what it came with, to be honest. But one thing I did do was I made a sound effect. Melodic loss 1. That's the sound you hear. And I set the loop to false, meaning it only plays it one time. If I set it to true, it's going to loop it, meaning it's going to play it over and over. Okay, listen to the sound. It plays over. I guess because the sounds, there it goes. So it's kind of replaying the sound. Oops. Set it to false. Okay. Let me refresh this. What was the second thing I did? It's hard to see what it came. Oh, I think I added the scoreboard. That's the second thing I did. So to do the scoreboard, so here's the scoreboard. Again, it's set to false, so it's not repeating the sound. The scoreboard, I just simply set the text size to 36, put the score as a text. That's this part right here. And then set the where it types, and then the variable score. And then down here, oh, did I not set it? I should have had it. Oh, I didn't do that. So, oh, it's because I didn't want to design the game. But what I would do is, once I kind of fix the speed, what I would do is I would add another code or effect where when the frog is touching, I would make the variable score to be score plus 1. So I just add another point. Okay. The reason it does, oops, it shouldn't be on that one. It should also be if the frog's Y value is above, you know, when I jump over the mushroom. But we're not going to go over all that right now. Okay, and just a review. And let's start looking at 17. All this is going to be a one long video. Okay, so lesson 17, we are going to be looking at the complex sprite movements, specifically how they jump and how they move faster or slower. Okay, here we are supposed to make a prediction, seeing what happens, and I noticed here where it's saying that the velocity x, which is the speed if you remember, is in every time you draw it, in every frame it's going to increase by 1/10 each time. So you're going to notice it goes slower and then moves faster, 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 faster. Number 3. So we're going to look at the velocity x property and the counter pattern together. The counter is the when we add the 1/10 each time. This is the counter. When I say the counter pattern, it's when we add something or subtract something each time. So I think this is actually reset again. Let's start over again. So what we're going to want to do in this is we're going to make this car speed up. So if I run the code that's given, the car is really slow. So instead of just changing the velocity, we want it to speed up gradually. So we're going to use a counter pattern for that. And to do that, I'm going to go to the variables. I'm going to go ahead and drop it down here. We're going to set the car velocity x value to be car.velocity x plus, let's just go up by 1/10 each time. So you're going to notice it's speeding up, okay? Each new frame, it speeds up a little faster and faster. If I do a higher number, it's going to increase or accelerate even faster. And if I do a whole number, even faster. All right, so that's number 3. Number 4 is kind of the same thing, except now we're looking at the y velocity. So let's go ahead and run it. And it's dropping, but it's dropping pretty slowly. So we're trying to simulate gravity, right? We want it to drop faster and faster. So same thing as before, we're going to change the y velocity. Before I do that, I want to once again remind us that as y increases, it's going downwards. Okay, so oops, we don't want that. We want to set the variable rock velocity y is going to be rock.velocity y plus, let's just say 0 and 1/10. So it's falling faster and faster. The challenge is we simply just add a rotation. Okay, we add a rotation speed. We can add it here, or we could also make it rotate faster and faster. Let's just set it to rotate. And let's set maybe 2 degrees. Okay, if we wanted to rotate faster and faster, we could add a counter pattern down here as well. Alright, number 5. Oops, let's reset. We're going to make the bubble rise faster and faster. And this is where we want to remember again, y velocity, if it's going downwards, the y is increasing. It's opposite of your math class. When it's going up, it's decreasing. So the velocity right now is negative 0 5/10. To make it move up more quickly, we're going to use the counter pattern. Bubble velocity y is going to be bubble velocity y minus or adding a negative. Let's start with adding a negative 1/10. And we notice it's going up faster and faster. Of course, as we change the negative value to a larger negative, it goes faster and faster. Alright, number 6. Once again, I'm going to reset it. The car is going into the water. Oops, let's look over. Now we're going to practice slowing things down. So the car is going to the water, and we want to slow down so we don't touch the water. We don't want to run the car into the water. So we're going to use the counter pattern to slow it down by 25/100ths as it moves across the screen. Okay, so car velocity x equals car velocity x minus, or adding a negative, we could use minus 25/100ths. And you're going to notice it slows down and it stops, and it even goes backwards because it's still going leftwards, or negative x. To make it slow down only if the velocity is greater than 1, we could use the if command. If, oops, no. Let's move this block. If car velocity x is greater than 25/100ths, it's going to almost stop. Okay. Oops, it said to do 0, but the reason I did 25/100ths is so it doesn't go backwards. Okay, so here I guess it's actually stopped completely. So if we do is greater than 0, it actually stops. Forgot why I thought differently, but it looks like that works. Okay, so we just made the if statement. Number 7. Let's reset it and let's read the directions after. In the last level, we slowed down the car. It looks like the car is getting pulled to the left. We did the challenge, so that didn't happen, but before that. If you use the same pattern with velocity y, the sprite's going to be pulled down, which is what gravity does. So the rock is thrown in the air but never falls down. Use the velocity x block with the counter pattern to make the rock slow down and then fall in the other direction. Experiment with different values. Do you want to change? So this is something you want to consider on your own, and this as well. So let's run it, and it's just going upward. So we're going to change the y velocity. Let's do rock velocity y minus plus, because we want it to go downwards. Let's start with 1. Okay, we'll try the different values. Okay, and that looks like it's a little too fast, maybe 5/10. Okay, so you could kind of change it how you want to, but that's the main part of number 7. Number 8. This is a completed game, so let me reset. This might be complicated to explain here. So increasing the y's velocity can simulate gravity. So that's what we're going to do with the sprite. We're going to make it jump, essentially. And to do that, we're going to do the if the arrow key is pressed up, we're going to change the velocity to -5. And we do show me where it's going to be done here. So if the key went down, we're going to make the velocity -5. Let's see what it looks like first. Right now, nothing happens. Okay, it just goes down. We have the flyer background. Velocity is already set, and the velocity is making the flyer or character go down faster and faster. So we want to set the velocity of y to so if that happens, the velocity of y is just going to be -5. Okay, we're not going to use the counter right now. Let's see what happens. Okay, now when I press up, it goes up. Okay, but it resets the velocity of -5, but then again, remember, it's continuously adding 0.1 each frame. That's why it's going back down. Alright, number 9. We're going to continue it now. Let's see what's happening. We're going to use the y velocity. Okay, we're going to use the x counter now to make it float from side to side. So we're going to add an if statement inside the one for the up arrow. Add an if statement inside your draw loop below the below it. There you go. That makes more sense. Below it, we're going to use the key down. So we're going to go to the right. If use a counter pattern. So if we press it, we're going to go 0.1 to the right. And then we're going to run the code to see if it works. And then we'll remember we're going to do the left arrow in the next level. Okay, so simple enough. Let's run it, and that's the same code as before, so we don't really need to look at it too carefully. We're going to go ahead and add the right command. So if we press the key to the right, okay, what do we want to happen? Well, if we press it to the right, use a counter block to add 1/10. So it's a little different this time. We're using the counter block. Oops. I guess we could have, I've been doing it differently because I type. I guess we could even use these, right? Is that what most of you guys are using? Anyways, character velocity x is now going to be character velocity x plus 0.1. Okay, just following the directions it gives us. Okay, and when I hold to the right, it's going to the right, and notice it's floating. Okay, if you guys try this out, notice it keeps going that way. There's nothing countering it and going back to the left. Okay, now to float to the left. Last time we did to the right, now we're going to do to the left. Hopefully you're feeling comfortable using the velocity and counter patterns. If you're having trouble, it says talk to a neighbor, but contact me, leave questions in the comments, send me a loop mail, come to tutoring. If you can't make it a tutoring at that time, send me a message, we could arrange a different appointment. Or, and this is what many of you guys do, review some of the past levels you've already worked on. So now we're going to add code that makes the sprite start moving to the left. So essentially it's going to be what we did here, but it's going to be the opposite way. Make sure you're using velocity and counter pattern together. Okay, so we could simply copy and paste. I'm going to use the lasso tool, drag it and do the rectangle, copy, Control C, paste, Control V, and I could just change all these to the left. And instead of plus 1/10, I can do plus a negative 1/10 or minus 1/10, and that really does quickly make short work of it. Now I could go to the left as well. Okay, so this is where you want to consider how your controls feel. If you want to add or change some values, you could do that. You could do some wonky things like make it the opposite. It's really up to you. Just make it fun, right? What kind of fun game can you do? And we're actually going to be working on this more towards the end. Let's continue. Okay, here we're going to add a coin. So we're going to be continuing the game by adding a coin now. We're going to start by creating a sprite and a coin. So we're going to go to animation. It already has it, I guess. They already came with it. They came with name. I don't remember if I added this or if it came with it. So we already have the coin. Sprite X and sprite, use the sprite X and sprite Y properties, give it a random X and random Y property. Oh, we have to actually create the sprite. That's what we want to do. Sorry about that. So that's what the first thing is saying. So I actually don't even know how to make more space, so I'll just kind of clunk it together. We're gonna have a variable coin. We want it to be at a random place. I forgot the order of how we learn things. Do I want to make it random now? Let's go ahead and leave it. Yeah, let's go ahead and just make it random now. I guess I think we want to. Oh, sorry about that. So I wasn't thinking clearly. We haven't drawn the sprite yet, so we could just create it in the very middle. And what we're going to want to do is we're going to want to go ahead, or do I? Let's actually do it here. I can't remember the order. I'm sorry. So we're just going to make it random right now. So remember the 200, 200 is in the very middle. 200, 200. We're just going to want to make it a random number. So we're going to say, here we're going to do random number between 0 and 400. And here we do random number between 0 and 400. So that's going to make it random, come up at a random place, position. We're going to set the animation. Coin, and the animation is going to be the coin. So let's just double check to make sure it works. And we notice that the coin is at a random spot. I think that's all for this one, so we're going to move forward. Here, we're going to reset the coin when we touch it. So place if block inside of the draw loop. Let's go ahead and do that. If the sprite is touching, if the coin touches the character, should have done character touches the coin, but in this case it won't really matter. What do we want to do? Detect when it touches the coin. If it touches each other, we're going to reposition or move the coin. So right now when it touches it, nothing happens. So what we want to do is now we're going to say if they do touch, we're going to change the coin's value to a random number between 0 and 400. And same thing with the Y, coin random number between 0 and 400. Okay, so when it touches now, I see what happened. Okay, so now when we touch, you're going to notice that it kind of disappeared. And that's where I kind of ran into trouble up here. So I'm actually going to reset this. I'm going to change this to 200, and 200. And then here I'm going to set the animation effort, the X position and Y position to a random number between 0 and 400. Random number between 0 and 400. Okay, I think that should fix my error. Okay, still not working. Let's take a look at what's going on. What did I do here? If the coin is touching the... I wonder if this is why I should change it. No, that shouldn't matter. If the coin is touching X and Y position, changes again. I should move somewhere on the screen. Okay, so I know what I did. Jeez. I set the velocity to a random number. I don't want to change the velocity. I want to change the location. So I just want to do coin.x and then coin.y. Okay, that should work now. Okay. There it goes. So you'll notice that I do some of the kind of simple or silly mistakes all the time as well, and you know that's all part of the coding and debugging process. Now I'm going to go and finish next one. Now we're adding mechanics. What do you want to happen? Should you get points? Make a scoreboard. I had a lot of that, so I'm actually going to reset it, and if you've seen my other video, you'll probably see a lot of the different ones I had. Let's go to the one from, I think this one should work. So I did add the scoreboard. I made a bad coin. I explained that in the other video, so I'm not going to go over that too much. Oh, I did delete these squares, and how I did that was I was in the middle of making the borders and I never finished, so I'll just erase that. And the game should work. We could turn the debugging to false if we want, but I'll leave it for now. Okay, so I'm not going to go over all this. You could watch the other video because it's really you using some of the things we learned today. Okay, and number 14 is a review. Please make sure you guys take a few minutes to, if anything, skim through the review so you continue reviewing what we covered in today's lesson. Let's move on to 18 now, where we talk about the different types of collision. We're going to talk about bouncing, bounce off, collide, displace, and the bounciness. I'm not going to talk about this because I talked about this in the other video, but essentially you're going to look at the code and kind of imagine, or in your head kind of put together some of these codes to see how it works. So you're probably going to combine this touching with the velocity variables to and an if statement to program them. Number 3. What are we doing? Number 3. You're going to program it yourself, and what you're going to do if we run it, we're going to notice that once the giraffe touches the monkey, it just goes through it. So what do we want to happen? Okay, so I guess we're going to start with if. They didn't give us an if variable. If the, what was it, giraffe touches the monkey, what do we want to happen? There's a lot of different things we could do. Simplest one is, since the giraffe was set, the velocity was set to 1, we could say that when they touch, the monkey's velocity is also going to be 1. If you're really good with math and the coding, another thing you could do, instead of typing the number, you could use the variable giraffe. Giraffe velocity, velocity x, meaning if they touch, the monkey's x velocity is going to be the same as the giraffe's x velocity. And if you run it, it's going to look the same. Because the giraffe's x velocity is 1, we're going to set it to be the same thing. Alright? Number 4. Let's reset. We're going to do another interaction. Oh, and here you're going to have the elephant push the hippo off the screen. Notice the elephant moves at a random y velocity this time when the program runs. So right now when we run it, it's currently just, I believe, moving through it. Yeah, just the elephant moves through it. Using the patterns from last level, write the code that makes the elephant push the hippo off the screen. Okay, well, the elephant's y velocity is a random number between -3 and -1. Hippo stays the same. So this is where you have to do what I mentioned in the last video. If they're touching, if the elephant touches the hippo, what do we want to happen? We want to set the elephant's y velocity to make it the same as the hippo's y velocity. We were hippo, not hippos. And when we run it, we're going to notice that they kind of push the other off the screen. Oh no, we have to do the other way around. We have to set the hippo's velocity to be the elephant's velocity. Okay, now it should work. Alright, number 5. Now we're going to look at the displacing command. So that's going to be the interaction that we programmed just now, except we just have a code for it. We're going to use sprite displace. So again, here we programmed it manually by setting the velocity to be equal to each other. Now we're just going to use the displace tool. So they're trying to use it, but there's a bug, so we're going to change the code. And so let's run it, and we notice the elephant is displacing the hippo, but we want the hippo to push the elephant. We want the hippo, sorry, the hippo is pushing the elephant. We want the elephant to push the hippo. And I think that was the mistake I just made just now as well. Do they have the show now? They don't. But they use the hippo displacing elephant command. We need to switch it because we want the elephant to actually displace the hippo. We want the elephant to push the hippo, or we want the hippo to take the velocity of the elephant. Alright, number 6. Let's reset it. This is where you're actually just practicing the different, or looking at the different interactions and how they'll affect each other. And they actually even say switch to text mode. I guess it's easier to do that. So right here, the parrot's displacing the penguin. We just want to see what happens. So instead of doing that, what if the parrot collides into the, what was the other penguin? So different type of interaction. I'm going to use the text because it's easier. Instead of colliding, what if it bounces? And what if it bounces off? Okay, I want you to notice the difference between the 4 things. Alright, number 7. We're going to now use the 4 displacements. Oops, let me reset. And let's go to the block mode. We're going to now look at decide which of the 4 we want to do. So for the basketball, do we want to bounce off, collide, or displace? Okay, and really you probably aren't too certain of the differences yet, so you'll just try one out. So we'll do the basketball bounces from the floor. Oops, wood. And okay, we notice, hey, we don't want the wood to move, we want the basketball to move, so we just simply switch it. Oh, wait, we're using the bounce command. So that should have been right. Basketball wood should be displacing it. So we don't want that to happen, sorry. So we're going to now switch it, okay? Well, what if we do displace instead? Okay, is that what we want? Probably not. Let's switch it. And still not what we want because we're not displacing any of them. Let's do collide. Nope. And we know it's not going to be either of those, so let's switch to bounce. Is it this? And it's not this, so basketball and wood. And we're noticing this won't work either, so we'll try the bounce off. Okay, and finally the last one works. Alright, number 8. So this is the turtle one. I also did this in the other video, but we just want to emphasize that the interactions are not remembered, so you need to make sure you set it each time. So this turtle is not, we don't want it to go behind the tree. So we have to figure out what's wrong with the code. So we ran the code. Now let's look at the code. We have the turtle collide here, so why is it not working? Because collide should not let us touch it. So hopefully what you notice is, wait, this is not actually in the draw function. What if we move it into the draw function? Let's see what happens. Now I can't have the turtle into the tree. Alright, so we just had to make that change in number 8. Number 9. Which one is this? Let's reset it. Basically, this is the debugging one. And essentially, we're gonna want to practice using the debugging. There's two coins, so we're trying to figure out what's wrong with it. So the first thing we want to do is see what happens, and we notice that it bounces in a weird direction. It doesn't even touch it, but it bounces away. So we're gonna set the debugging to true to see what's going on. And we're gonna notice that the reason it bounces early is because the proximity or the parameters is a square parameter. It's not actually around the coin. So when those squares touch, it's already bouncing. So now let's go ahead and just make one quick change that they asked us to. Change the X position of 51 of the gold coin. Remember, this is X and Y, so we're going to change this to 51. And this should bounce more, I guess, as we sort of expect. We'll learn how to change that in, I think, the next one, but that's all we need to do for 9. Okay, there we go. So in number 10, this is where we're going to change it. This is, where it bounces weird. They added a set collider block now, and that's what this is here and here. So instead of that rectangular, we want it circular, so we just change this down here to circle, change this to circle, and now the colliders are a circle. Now it bounces as we actually do expect. So that's the set collider. That's a new block we're learning in this puzzle. It's very simple, but it's very important. Okay, number 11. Let's see, let's start by resetting it. Basically, we're going to learn about the bounciness now block, where we see how bouncy the balls are. So we want these to bounce at different bounciness levels. In case we weren't 100% certain, basketballs should be the most bouncy, soccer balls second most, and pool balls barely bounce at all. So that's the block here. This bounciness is set to 8/10. This is 4/10. And, this is 8/10. Soccer ball hasn't had anything set yet, and this is 4/10. So let's set this to, let's just set this to 1. Let's leave this as 4/10. And let's just add a number for the soccer ball. We're going to look for the bounciness. The soccer ball. And let's set this to maybe somewhere in the middle, 8/10. Let's run this. And I think this is a good level. Notice how the pool ball barely bounces. Basketball is the most, and soccer ball's right in the middle. Okay, the next few, you're continuing your game. In this one, we're setting the... What do we do? Oh, we're going to add an obstacle. Let me see if I have one here. Oh, I already have mine here, and I'm not going to reset mine because I have to redo all the old stuff as well. But what I did is I did add an obstacle. It was a lollipop in my case. You can choose what you want. I made sure to set the collider to a circle because mine is a circular shape. If yours is a rectangular shape, use a rectangle. And then I guess they don't tell you use the collide, but you definitely want to make sure that maybe it's in the future one, but you want to make sure that you can't go into that. You can't collide into that lollipop or whatever your obstacle is. And 13, again, same code. I'm not going to reset it or do anything. This is just kind of the bounciness of the obstacles. Do you want to set it? That's going to be up to you. For mine, did I set the bounciness? I don't think I did. I guess I didn't set anything, but I definitely could by using the bounciness. Where's the bounciness? Right here. Maybe, oops, we don't want to do the obstacle, right? Let's take a look at what happens when we do this. Okay, so I guess that kind of works. So we can set the bounciness to what we want, more or less. I'll just leave it, it's not a big deal. And number 14. We don't want the code to be behind the obstacle, so let me show you what I did there. What did I do there? Animation. Okay, there it is. So when I set the coin, no, it's not there. I think it's somewhere in the if statement. So in the draw function, if the coin is touching the obstacle, where is it? Character is touching it. Oh, here's where I set the bounciness obstacle for the character. I set one for the obstacle as well. Here it is. When the coin touches the obstacle, I make the coin move again. I move it to another random location. Okay, so that's what this is here. So if the coin is touching the obstacle, coin X, random number, coin Y, random number. I can't really show it because it moves right away, but you'll notice that each time the coin is never on the obstacle. Okay. Number 15. This is kind of where we set the debugging to true for the debugging properties. We set the colliders to a circle because I just had coins. And I think that's pretty much it. After that, you're just creating your own game, and you could share this. Once you're done with it, you could click share, and you could send a link to people, and they could play your game. So if I do this, this is going to be what it looks like. So you want to set the debugging off perhaps if you're sending it out, but this is what it would look like if you send your game to someone. Okay, I think that's it. Number 17 is review, and that is this week's lesson.